Before we go to amides, let's just recap to make sure you remember that for amides, it's ammonolysis that makes the amides, where you add ammonia to carboxylic acids and to esters. So it's ammonolysis to esters and carboxylic acids. When you add ammonia, then and put a little bit of heat, then you're going to make your things. Remember that all that happens is in ammonolysis, the double bond is not touched. It's the bond breaks here. Soon after that double bond, that is where it breaks, okay? And you can break it. And this, right after that, is where your NH2 is going to come, okay? This is where your NH2 is going to come, and you're going to have it like that. Now, what you must also then know is the reactions. For the reactions, we saw how you have your amide and you have the acid hydrolysis. And for hydrolysis of amides, it's easy. Just remember that break the bond here, and then for here you put for here you put OH minus, you put the negative ion, okay? So for here you're going to put OH minus. Then everything else which remains, which is for my water, I took only OH minus. That means the H plus is still there. And then I have HCl, okay? HCl, remember I use HCl. It means that the H and the Cl, you still have them. So remember that you're going to take this H and then this from water. You take the H plus and the HCl and you bring them all and they come like this. This H and this H come and they come NH2 bonded to this and this. Then it becomes a positive because it now has 4 bonds, which is too many. So it now becomes positive. Then the chlorine can then be attracted because chlorine is negative and it comes, okay? The OH would have come to the carbon, right? Remember the bond breaks here. And the same thing happens in base hydrolysis. The bond breaks here. And when the bond breaks here we are going to take Na and O, and they're going to come. Then we have OH remaining. It's obviously, H remaining. It's obviously going to go to this thing, and everything which remains is bonded together. That's what happens. Now, there's one more thing which I should actually put, one more reaction which I had left, which is going to be reduction of amides. You can reduce amides, okay? And their reduction is a little bit different from the other ones. From the other ones, we know that the double bond O becomes an OH and an H also comes. And we know that anything like an OH or whatever, it goes and you put an H. But for here, for amides, what happens is you remove the double bond O and you put 2 H's. That's just what happens when you reduce. So it's like you have your C double bond O, and then you have your N. We don't care what the N is bonded to. It could be bonded to a hydrogen and a carbon, or hydrogens or carbons, we don't care. But this is what we want, C double bond O right next to an N. That's an amide. Then if we reduce using what? We use LiAlAH, H4. Remember that. It's LiAlH4. Okay, and we do put it in ether. Lithium tetrahydroaluminate. What happens? 2 hydrogens are going to come here. So it's just going to be RC, 2 hydrogens like that. Then goes to bond with the N and nothing changes here. It's R prime and the H. So just remember that. And that water, that O that goes is just going to be then released, of course, or is it probably as like water or something, okay? As a byproduct, so, right, I assume. Now, this is going to be the reduction. And when we go to amides, which you're going to do in the next video, you're going to see that this is going to be how amides are made. That is one of the ways in which we make amides. We have 2 ways to make amides, and let's go see it in the next video. Goodbye for now.